Hi, everyone. When we're working with word problems, thank you for showing up for your learning, by the way. When we're working with word problems, it's very important that we can identify whether we need sine, cosine, or tangent as the angle, as the trigonometric ratio that we're using. So when we're looking at something like this triangle, we want to remember that the longest side is always the hypotenuse. If this is the angle of interest, the side opposite is the opposite. And then the adjacent side is the adjacent to the angle. Okay, don't be sarcastic, Mr. Jennings. It doesn't help you learn. All right, so let's keep going. So then you consider your different trigonometric ratios, and you have SOHCAHTOA as something that I'm going to say somewhere between 17 and 500,000 times in this unit. Okay, SOHCAHTOA. It means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. There are three sides, and there's three different ways to have a pair of two. Okay, so sine is the one that has a pair of opposite and hypotenuse. Cosine is the one that pairs adjacent and hypotenuse, and tangent pairs opposite and adjacent. All right, so that's the different trigonometric ratios that relate to all of those things. So when we're working with a word problem like how tall is this tree, okay, and we have a measure 24 meters there and 40 degrees. That's actually enough information to find that the tan of 40 would be the height of the tree divided by 24. Why is that? Well, the height of the tree there is opposite to that angle 40 degrees. The side 24 is adjacent. Tangent is opposite over adjacent. And then you just do algebra and solve. So let's take a look at our lesson for today. Applying SOHCAHTOA. So we are going to now apply this to problems involving sides and angles in right triangles. Only right angle triangles yet. Next unit will be non-right angle triangles in real life applications. So let's take a look. So first, again, let's draw some triangles here and we'll take a look. Let's say I have a hot air balloon in the air here. Okay, here's my hot air balloon, and I know that this is the ground, and it's flat here. We're not on a hill. And this is us. We're way over here, and we know that this. Maybe we use a like a range finder, and we find this distance here. Okay, and we used a laser pointer to measure this distance, or a laser tape measure, and it told us that this is 1.5 kilometers away. Okay, and we want to know how high is that thing. We can also measure our viewing angle here, and we would use something called an inclinometer. It's like a protractor with a weight that hangs off of it. So as you lift up it measures the angle. As you lift up, it measures the angle. So, and we measure this angle to be 17 degrees. All right. Now, we know this and we know this, and that's enough to determine the height and the distance away. Now, let's say we wanted to know the height of this balloon. What we would look at is what kinds of sides are we dealing with? Well, we know this angle here, it's 17 degrees, so that becomes our angle of interest. Then we look across the triangle, and we find that across the triangle is the opposite side. So this height is the opposite side. We know the hypotenuse. We used a laser pointer or a laser tape measure to find this distance of 1.5 kilometers diagonally, is its distance from us. So if we want to find that height, we can create a diagram. It might look like this. And then we're going to say this is the height, this is 1.5 kilometers, and this is 17 degrees. And we say what relates opposite to hypotenuse? SOHCAHTOA, S-O-H, sine. O and H are related to sine. So what we would do is we would say here that sine of 17 degrees will be equal to opposite over hypotenuse. Will be equal to the height over the hypotenuse, 1.5. All right. Now, we just need to do a little bit of algebra by multiplying both sides by 1.5. Why am I multiplying both sides by 1.5? Well, I'm interested to know what h is. So I want to get h away from this number here. This number is dividing h. So I use the opposite of division, which is multiplication. That will cancel. And now I have 1.5 times sine 17 is equal to h. I also make a guess. I guess that this is going to be substantially less than 1 kilometer. It's going to be fairly low. It's going to be like 0.5 kilometers, maybe even a little lower, like 400 meters perhaps. So this is how I punch it on my calculator. I go 1.5 times the sine of 17. And then notice this, 1.5 times sine 17. This is the value of sine 17 here. Okay, it means 0.29. So what that's telling me is this side will be about 0.3 times as long as this. Just like I said, it's going to be shorter than that. And now, if I push in equals again, now this is how many kilometers high that balloon is. So like I said, it's about 400 meters in the air, because a kilometer is 1,000 meters. So here it is, 439 meters. Therefore, the balloon is 400 and, did I say 439? 439. 439 meters in the air. Okay, now let's find how far we are away from it. Okay, so I'm going to do another diagram here. It's going to be the same diagram, but it's going to look a little different. We'll use a different color because it's a different question. And let's say we're now solving for D. And so here I have the same opposite, the same adjacent, and the same hypotenuse. And I'm going to let whoever that is into the lesson. Perhaps I'll let them in. Perhaps they will be gone by the time I get to you. Here we go. Tasha Bura. I think that might be someone's mother, but I'm not going to let a random name into the meet. They should log in with their SCDSB account, like all of you have today. Okay, so let's keep going. Let's keep going. All right, so someone is...
The random person that joined the meet is Ava. Sorry, her computer's like really messed up right now. She's on the phone with me.
Sure. Tell her to try again and I'll let her in.
Okay, thanks.
Yeah, I thought that was her, but I just I want to see. There she is. Welcome back, Ava. Okay, let's keep going. So here's our diagram, and it's still a right angle triangle here. It's still 1.5 kilometers there, and this is still 17 degrees. But if I'm solving for D, then I realize, okay, now I'm looking at the adjacent side, and I want the trigonometric ratio that relates adjacent to hypotenuse. So ka, there it is, AH, CAH, so ka toa. So cosine is adjacent over hypotenuse. So then I can write down the cosine of 17 degrees is equal to D over 1.5. Adjacent over hypotenuse, adjacent over hypotenuse. So D over 1.5. All right, now I make a guess. And I'm going to guess that this is going to be quite close to 1.5. I'm guessing that I'm about 1.2 or maybe even 1.3 kilometers away from this balloon horizontally. And vertically, I'm only, as we've seen, the balloon is only 430 meters in the air. So let's take a look at what that's going to be. So, right. So now I do some inverse operations. I multiply both sides by 1.5, just as I did here. And so I get 15 times cosine of 17 equals D, because these cancel. And that isolates D. I wanted to find D, so I've isolated it. Hoorah! Let's find out the value. So here, 15 multiplied by the cosine of 17. That's the cosine of 17. Notice it's a number very close to 1. That's how I knew that this would be very close to 1.5. And I push equals, and it's 14 point... I see why the decimal is in the wrong place, because I wrote 15 instead of 1.5. Okay, so this is 1.5. Okay, so I just need to shift the decimal place by 1 in my answer. 1.43. So 1 kilometer and 434 meters. So it's 1.4 kilometers. We'll say 1.4. We'll round. Okay, so therefore the balloon is 1.4 kilometers away horizontally. Like if I walk 1.4 meters from there, I will get to a point directly underneath the balloon. All right, so that's how you choose sine, cosine, or tangent. Now, if we're at 57 inches from the base of a building, okay, someone has written 57 inches, but that should be 57 feet, because that would make sense, unless it's a building for ants. If you've seen Zoolander, you'll get that reference. Okay. At 57 feet from the base of a building, you need to look up at 55 degrees to see the top of the building. What is the height of the building? Okay, so here, what trigonometric ratio am I going to use, everybody? Sine, cosine, or tangent? I'm going to draw it here. I'm going to draw a diagram. Someone said so in the chat. I'll go take a look. And we're going to see what people say. Oh, a hand is up. Yeah, go ahead, Hannah. You don't need to raise your hands. You can just shout at me, guys.
Is it sine?
We won't be using sine. I'll show you why. To use sine relates opposite. So you're right that like we're looking to solve for the opposite. So sine could do that if I knew the hypotenuse. But I don't know the hypotenuse, so I can't use sine.
Oh, I see. So it's tan?
Yes, tan. Because
Okay,
we take our
I see
known down here. Yeah, go ahead. Okay, so we take our known down here and our other known angle, and we say, what are we looking to find? And so we blend our unknown, which is the opposite, and our known, which is this 57 feet, not inches, and then this here 55 degrees. Again, another lover of Fibonacci numbers. Okay, and we say, what relates these two things? And it's TOA, T-O-A. Tangent is opposite over adjacent. So I can write this here, tan 55 degrees. And before I get an answer, make a guess. Someone shout out in the chat, how tall will this building be if I'm looking up at 55 degrees? Make a guess. And this is a pretty good angle. This is a pretty good scale. That's pretty well looks like 55 degrees to me. Who has a guess?
75.
Sorry? 75?
75.
75 is a great guess. Yeah, I think that looks really good. It's going to be longer than 57, but it's not going to be twice as long. So that sounds like a really great guess. Let's check. So we know that tan 55 is the opposite over the adjacent. The adjacent is given. So this is a little convenient because our unknown is on the top of the fraction. When the unknown's on the bottom, we have to do a little bit of doing to isolate it. We're going to multiply both sides by 57. So I have 57 times tan 55. All right, these cancel, leaves me the opposite. So next line is going to look like this. The next line is the solution. 57 times tan 55 degrees equals the opposite. Let's punch that into our calculator and see what it says. Clear everything. 57 times 55. Take the tangent of it. That is the tangent. Okay, so that's not the answer. That's the value of tan 55. That's saying this is 1.4 times as long as that. Then push equals. 81.4. See how great that guess was? 75, now 81. And we can now say, okay, I was a little low, but next time I have to guess something like that, maybe I'll guess even closer. So that's great. This is 81 feet equals the opposite. So therefore, the building is 81 feet tall. Now, wasn't that easier than going to the hardware store and saying, I need a tape measure that's like about 100 feet long because I'm going to climb a building, get access, and go up there and put it there and then dangle it down and have my friend be at the bottom and hold it steady so that it doesn't get captured by the wind, okay? Trigonometry, a lot easier than doing these otherwise. Now, here's some definitions again. If we're in this balloon and we look down, that's called an angle of depression, an angle below the horizon. If we look up at the building, that's an angle of elevation. If we were to measure this angle of elevation here and this angle of depression, they would be the same. Why? Because Z pattern. This line is parallel with the ground because the ground is horizontal and so is this line by definition. And then Z pattern means if this angle is X, that angle is X. They're the opposite angles. Okay, so here's an example. And I wanted to expand this one. Find to the nearest tenth of a foot the height of the connection point on the tree and the, oh, it told us the length. Okay, all right. And the distance here. So if we want to find that one and that one, we would use different trigonometric ratios. Okay, so here, we want to know, we know that we're using an 8-foot line and we want to attach that to a tree to help it grow, and a 42-degree angle is optimal. So how high up the tree do we need to attach our 8-foot line so that we achieve an angle of 42 degrees? Basically, we're saying solve for x. So now what trigonometric ratio will I use here to solve for x? I wish I had a button I could push and it just plays Jeopardy music. Sine, cosine, or tangent? Shout it out. Incorrect answers welcome. Is my internet off? Sine, cosine, or tangent?
I may be wrong again, but is it sine because 8's on the top, like on the hypotenuse?
It is sine.
Okay.
Yes. Let's analyze our triangle here. 42 degrees, and we look across, we see, I want to know the opposite. I already know the hypotenuse. I know the longest side. So sine is opposite over hypotenuse. Sine relates these two things. So sine is going to rock and roll. Now, let's go for it. So we don't have a lot of space to do this one, but we see there's not a lot of algebra for these problems. It's really setting it up correctly, and that's going to help us solve them. So if I write this down, sine of 42 degrees is equal to the opposite over the hypotenuse. So it's equal to x over 8 feet. Multiplying both sides, because I'm dividing my desired unknown. So I'm dividing it by 8. So I'm going to multiply by 8 feet to isolate x. This cancels this. And then I have what I need to solve for right here. This is what I punch on my calculator. That's the answer. So here we go. 8 times the sine of 42. That is the sine of 42. So it's saying this is about like 6.7 times as long as this. How long is that? Equals 5.35. And we were asked to find this to the nearest tenth of a foot. So 5.35, there's the nearest tenth, but I need to round that up because 5 makes it round up. So it's going to be 5.4. Therefore, the connection point should be 5.4 feet up the tree. Cool. Okay, now we found how tall it should be from the tree. If we wanted to find that, what would we have done? Like if we instead wanted to find where should I put this stake, and then I'm just going to connect this wire. What would we have done if we wanted to find how far away the stake should be from the tree?
Use cosine.
Great, because cosine would have related the angle to the adjacent side and the hypotenuse. So cosine is adjacent over hypotenuse. And notice, just imagine this in your mind, that knowing the height I should attach to the tree is just as useful as knowing how far away it should be from the tree. Because if I attach the wire here first and then brought my 8 feet down, this would be the exact point and the only point I would find to stake it in. If I first staked it in there and then lifted it up as high as I could up the tree, it would have been the same. It would have had the same result. So finding this or finding that would both be acceptable ways of answering this question. But here we were asked to find the height of the connection point. So we would use sine. We would do this. Now, here is another question where we are up a fire tower and we look out along the flat, and then we look down here. On the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. Okay, if the tower is a known height, and when he's up there, he can very easily measure these angles or guesstimate them. Okay, and we want to know how far away is his partner to the nearest tenth of a foot. So I don't know why we need this much accuracy. Maybe we are, I don't know, sending a paper airplane that has a very precise trajectory. I don't know. And it's a windless day. Who knows? We want to know x to the nearest tenth of a foot. So in this case, first of all, I don't have any angles in this triangle. How can I get some angles in this triangle? I have an angle up there, but it's not part of this triangle. What can I do?
You have to use the Z pattern.
Beautiful. Thank you, Ashley. That was Ashley, right? So these two lines are parallel. This angle will be the same as this one. And now we've got an angle in there. Now this triangle has an angle, and we can solve it. So which trigonometric ratio will I use to relate this aside to that aside?
Tangent.
Excellent. So tangent is, which one goes on top?
Opposite.
Opposite.
Yeah, and in this case, opposite is x or 45?
45.
Excellent. So tangent 45 is equal to opposite, because that's opposite this angle, over the adjacent. So 45 over x. So I use some inverse operations here. I'm going to multiply both sides by x. That cancels here and here, and it brings it to the top on this side. But then I'm multiplying x by tan 40, and that's not convenient. So I'm going to divide tan 40 from both sides. All right, these x's are gone, and so I have, and these cancel on this side. So now all I need to solve is x equals 45 divided by tan 40. This is what I punch on my calculator to solve this question. There's extra doing when your unknown is on the bottom. First, move it to the top on the other side of the equation, and then move this tangent 40, which is just a number, move it to the bottom on the other side. So let's do that on the calculator. Okay, so we're going to write down here, clear everything, 45 divided by, and then I'm going to write down the tangent of 40. Notice it's 45 divided by tan 40. This is tan 40, okay? It's telling me that if I'm looking down at 45 degrees, this will be shorter than that. And that should make sense, but it's pretty close. It's almost 1. The ratio is almost the same to the same, because if this was 45 degrees, they would be the same. Okay, because it's 40, this is a little bit longer. So let's see, what's our answer? Should be a little bit longer than 45, and it is. It's 53.6 feet. X equals 53.6 feet. Cool. Now, there's one more thing that we're going to look at, and that's when we have triangles within triangles. And this was the other question that brave soul who put the questions in the doc. This is one of the question types that they asked. This is going back to similar triangles, but it's going to show a technique that I'm going to use to solve these more tricky problems when we have conjoined triangles. So here, PQ is parallel to MN. Okay, so these lines are parallel. All right, what that means is, oh, someone has a question. Hold on, let's see what your question is. Oh, Johnny, yeah, what's up?
Sorry, what's a conjoined triangle again?
Oh, like triangles within triangles, where like, you know,
Okay.
if I look at this diagram here and I say, how many triangles do you see? How many triangles do you see in this diagram?
2.
2, yeah, great. But see how they're superimposed?
Yeah.
Yeah, so they're conjoined, right? It's like conjoined twins. You know, like there's another word for Siamese twins. Do we say Siamese twins anymore? Maybe we don't. Anyway, people that are you know, put together at birth at the hip or at the side of the head or something like that. They're conjoined. They're joined. They're connected. Okay, so anyway, angle O is always angle O. We could call it X, right? And then using F pattern here, I'll just get another color so it shows up nicely. Using F pattern, because those two lines are parallel, I can show that this angle, if it's y, then that angle should also be y because they're being crossed by the same transversal. Okay, so what that's showing me is that, and if this is x and that's y, then by similar argument, this would be z, and this would also be z. So when you've got two triangles that have the same angles, they're similar. So we've proven that the triangles are similar. Now let's see if we can solve the question. So first it's telling us PQ is parallel to MN, so I put that on already. If PO is 12, so I can write that down, 12. And MP, this little bit there, is 6. Okay, and OQ is 14. Find the length of ON. Okay, so we want this whole length here. All right, now when I'm faced with a problem like this, my brain starts to bubble a little bit, and I'm a little bit like, I'm getting confused and I might make a mistake. So what I do is I draw two diagrams. I draw two triangles. So I'm going to draw the smaller triangle and the bigger triangle. Here is OPQ. OPQ. Here's Q, and this is O, and this is 14, okay? And this is 12, and this is P, all right? And I know that it's similar to this bigger triangle, OMN, okay? Here's ONM. So I'm like the surgeon that separates the conjoined twins at birth or later on in their life. You know, they get separated and then they can lead their individual lives. Okay, so OMN. All right, now, what's the length of OM? Well, it's 12 plus 6. Okay, that's really the trick here. This is 18 long, and I want to know this. So call this length A. I don't know. We need to find A. So because these two triangles are similar, the ratio of OM over OP, or 18 over 12, is going to be equal to A over 14. Okay? And so that's going to help me solve for A. And I can look at that and tell you it's 21. But another thing I could have done this, and it would not be wrong, it would just be more annoying. I could have put A on the bottom, and that would be annoying. Okay, I could have said 12 over 18 is equal to this 12 over 18. See, these are related sides here and here. So when I put them into a ratio, it should be the same as this side over that side. Okay, this would be 14 over A. And that's more annoying to solve because my variable's on the bottom. My unknown is on the bottom. So here, putting it on the top means I only have one thing to do. It's multiply both sides by 14. When I multiply this by 14, here's what I get. I get these canceling. And then I get, so I have A isolated, so that's great. And all I need to do is work with this. Here, there's a 2 that cancels out that 2, so that's now 7, and this is 6. And then the 6 over 18, there, that goes in evenly, so that's now 3, so it's 7 times 3 is 21. 21 equals A. Okay. That's just evaluating 14 times 18 over 12. Okay, and you'll find that that's 21. Watch. 14 times, misclicks. 14 times 18 equals a very big number that's hard to work with. Divide by 12 equals 21. There you go. So, there. That's how you do that. So that's like conjoined triangles. So that's how I manage conjoined triangles, is I'm going to draw separate diagrams. Let's take a look at a trigonometry example. Here's a multi-triangle example. We are told that there's two ladders, okay? And there's one ladder here leaning against the building of length 12. And there's one ladder here leaning against the building of length 18. We're told that this triangle leans at an angle 34 degrees. Again, some lover of Fibonacci numbers is making these problems. It's not me, folks. It's a conspiracy of math teachers. We love Fibonacci's. Okay, so anyway, 34 degrees. Two ladders are leaning against the building. And we want to know what angle this shorter ladder is leaning at. The problem with this question, if I draw this triangle here, okay, and I'm going to do that in in yellow here so that it doesn't really obscure what we're looking at. If I look at this triangle here, and I draw myself a diagram up there, I'm going to find I got a lot of unknowns here. It looks like this. So the wall, the height of the wall is there, comes out. I know that that's a right angle. I'm looking for that angle there. I want to know this angle. Call it theta. Okay? And I know that this is 12 meters, but I can't find that angle without at least one other known. Because it doesn't matter what trigonometric ratio I choose. If I choose sine, it relates this to this, and I don't know that. If I choose cosine, it relates this to this, and I don't know that. Okay? But I can use this other triangle here, and I'll show it to you. This other triangle I'm going to do in green. It comes down here. It goes out all the way over there, and it includes one known angle and one known side. And wouldn't you know, that's enough for me to solve that whole triangle. Okay, here's 34 degrees. Here is a right angle, and here is 18 meters. If I can solve this, which is the height of the building, then I will have one more known in that triangle. Suddenly, I would be able then to solve for theta. Okay, so let's do that. Let's solve for the height of the building, and that solves this side, which is the common side to both triangles. That's the side through which they're conjoined. Okay, so let's take a look. How will I solve for the height of the building using this triangle? Sine, cosine, or tangent?
Is it tangent?
Tangent will relate opposite to adjacent.
Oh, sorry. It's cosine.
Cosine would relate adjacent.
Sine.
Sine. Yes. Good. Good. So this is the opposite side, and it relates. And sine will relate this and this. Okay. So now what we're going to write down is sine of this angle, 34 degrees, is equal to the height of the building opposite over hypotenuse, which is 18. So now let's evaluate h. We're going to do that by, of course, multiplying both sides by 18. And now we get 18 sine 45 is equal to h. So what is 18 sine 45? Let's find out. 18. Now, I can't do these things in my head, but I always like to guess, okay? I am going to guess that it's 10.2. Anyone get closer than my guess? Anyone want to chance it? See if they can get closer than my guess? Who can
18.1.
18.1? Okay.
Yeah.
I will beat you because it can't be longer than the hypotenuse because the hypotenuse is the longest side. Also, by my diagram, which isn't so terrible a diagram, this is, if I rotate it up, definitely shorter than that. Maybe a little more than half. So I chose 10.2. Let's find out. Okay. 18 times the sine of 34. This is the sine of 34. Looks like my guess is pretty close, 10.1. 10.06. So we can keep a little bit of extra detail, 10.07, okay, because I saw that it was 10.065. So this is 10.07. So we'll keep a little bit of extra detail so that when we solve for this angle, we get it pretty close. What is the angle below the shorter ladder? It didn't say to the nearest whatever, so I'm going to assume to the nearest degree. This will be plenty enough detail to give us that. Actually, 10 would be enough. So now, what I'm going to do is I'm going to take this value and I'm going to substitute it into this triangle. Okay? You can substitute into equations. You can also substitute into diagrams as you find new knowns. So this is now not h, it's 10.07, and now I can solve for theta. Okay? Now, solving for an angle was Wednesday's topic, yesterday's topic. Okay, so this is what it looks like. I set up like this. What ratio is going to relate this side to this side? Sine, cosine, or tangent?
Sorry, what side to what side?
This side here to this side. My two known sides. Because I can use the two known sides to find this angle.
Or is it hypotenuse and opposite?
Yeah.
What would that be?
Yeah.
So like sine.
Got it. Yeah. So this is what you write down. You write down, I'll just change colors here. So when we're solving for the angle, you can always change your color to the red pen. No, you don't have to do that. Okay, here. Sine of the unknown angle theta is equal to opposite over adjacent. So 10.07 over 12. If I was using 10 over 12, that would reduce to 5 over 6. It's effectively 5 over 6. So now what I'm going to do is I take the inverse sine of both sides. And so my next line might look like this. Theta is equal to the sine inverse of, always put this in brackets, and put it in brackets on your calculator as well. Or do it first and then take the inverse sine of it. Okay, so the problem is, what I'm suggesting is that if I do this, okay, this is what the wrong thing you don't want to write down is. 0 is equal to sine inverse of 10.07 divided by 12. Okay, I can't divide the whole thing by 12. This, my calculator will tell me error, because there's no angle that gives me a value of sine that's bigger than 1. But this number here, you'll notice it's not bigger than 1, it's smaller than 1. And so I can solve this. Okay, so let's do that. So I already have the 10.07 blah, blah, blah on my calculator. This is pretty much an exact value to the molecule of brick here. Okay, and I'm going to divide that by 12. I'm going to say equals. So this is the value of sine. Sorry, this is the value of sine that I'm looking for. So this sine inverse will solve for the angle that has that sine. Okay, so let's do that. Now I go trigonometry, second function. See how that gives me the inverse sine? I click inverse sine and it tells me 57 degrees. Oh, I should have guessed first. And I would have guessed 57.1 and I would have been wrong by 0.1. No, I'm just kidding. I wouldn't have been that close. I might have guessed 50. Okay, so theta there is equal to 57 degrees. That's how you do all of these question types, everyone. All of the question types that we're doing with right angle triangles this course, except for some 3D stuff. We are going to do some 3D stuff, if not tomorrow when we meet. And 3D stuff is basically like this. Okay, it's like when I have to solve for one side, and then that allows me to solve the next triangle. Okay, and we'll look at 3D stuff and drawing 3D diagrams later. You'll do a lot more 3D trigonometry in grade 11, just a little bit in grade 10 to get a taste. Okay, so I hope that was very clear for everyone. I have an appointment this afternoon, so I will be very much available by email. For those of you who haven't met with me yet about the very brief trigonometry investigation assignment, you could meet with me now, and then I'll head off to my appointment. So thank you very much for showing up for your learning, everyone who is here. You can always find me by email with your questions. Bye for now, everybody.